Deanne is the founder of Future Engineers, and also an engineer, and you've done television hosting and so many things it's hard to rattle off. But you're here because of Future Engineers, which is a really, really cool effort. And then we have Amy, is a communications specialist from NASA, which is really cool to have you here. And I'm going to hand it off to you two guys, and I'll be back on in about 20 minutes, and we'll do a little Q&A. And then we're going to do our citizen science panel. So I'm looking forward to that. So I'll see you guys in about 20 minutes.
Sounds good.
Awesome. Thank you so much, Dave. Hi, everyone. It's the last panel before happy hour, so we're going to keep the energy going. Give us a shout out on chat. I hope you guys are doing well. Tell us where you're chiming in from. We're really excited to be closing out this amazing session. Future Engineers presented at this second Science is Cool Unconference. We loved it so much that we're back for more. And so I'm going to actually start this presentation. So today we're talking all about the moon. And you know that we have Amy here from NASA, and she's going to talk about NASA's role in taking us back to the moon. Did you guys know that we're going back to the moon? So it's not just like this fictitious statement of like, we're going to the moon. NASA has an ambitious goal to go back to the moon by 2024, and that's soon, guys. So in an effort to engage K-12 students in this, we recently launched a K-12 student challenge called the Artemis Moon Pod Essay Contest. And so Future Engineers launched this challenge in collaboration with NASA, and I'm going to kick things off just by first introducing the challenge to you. It is entirely free, 100% free, so we encourage you to go ahead and register while you're on this session so that you can get your students involved and submit their essay. And I'm going to go ahead and switch over to sharing my screen. I'm just going to go ahead and share the contest website itself, give you a bit of a rundown of that, and then we're going to turn it over to Amy, who's going to give a really great overview of the Artemis program and NASA's plans to go back to the moon. So first, let's start by sharing my screen. Here we go. Do you guys all see that? A-okay? Hopefully, Amy, you see that?
Yes, I see it.
Great. Okay, great. You're the one that can talk back to me, so I got it. Okay, so I'm the founder of Future Engineers. So Future Engineers is an education technology company, and we operate a platform that you see right here that issues free online student contests and challenges. So Future Engineers, if you go to our site, you'll see all the challenges that are open, and the one we are talking about today is the Artemis Moon Pod Essay Contest. So this is our contest site. All the information you need to know about participating in this contest is right here on this site. So I'll give you a little overview. So it is for K-12 students, full K-12. You could be as young as kindergarten, as old as 12th grade to participate in this contest. And we're challenging students to write an essay, to first imagine that they were leading a one-week expedition on the moon and write an essay that tells NASA all about it. So we want to hear about the types of skills, attributes, and personality traits that you would want in your moon pod crew and why, how many would be in your pod. And of course, you need to talk about high-tech gear and gadgets. So we also want the students to describe one machine, robot, or technology that they would leave on the lunar surface to help future astronauts explore the moon. And since it is full K-12, we've broken it down into 3 different grade groups. So there's the youngsters, we've got kindergarten to 4th grade that are competing against each other. Then we have 5th to 8th grade and 9th to 12th grade. And you can see here that there's different word limits for the different age groups. If you scroll down a little bit more, you can see more of the criteria. So we have judging criteria. If you want to judge as well, you can volunteer to do that. We are going to be leveraging a volunteer judge force from across the country to judge all of these entries and determine our semifinalists, finalists, and winners. And the program dates, the important one to remember is December 17th. So that's when all of those essays need to be submitted to the website. So in order for your students to submit, they need to register. So a student can just do this on their own ambition and register individually. Or as an educator, you can register your entire class. So we encourage you to go there right now. Just go to futureengineers.org. If you go up into the right-hand corner, you'll see sign up. Sign up, and that'll take you through the registration steps. And if you need a little help on how to register, you can go to the Help Center as well, and it has some getting started guides on registration. And I also want to mention the prizes. So Future Engineers has put together a really cool prize suite in coordination with NASA. So the way it works is we have these different grade bands, but in that first judging, all the students are competing within their state. So we have 52 groups. We have the 50 states, and then we also have Puerto Rico and DC. And then the Pacific territories are bundled with Hawaii, and the US Virgin Islands are bundled with South Carolina. So each student will compete in their state within their grade band, and those semifinalists, so we're going to choose one semifinalist per state, per grade band, and they're going to win an awesome Artemis prize pack. And they're also going to be invited to a series of 4 virtual Artemis Explorer sessions with NASA experts. I should add that everyone that submits an entry gets a participation certificate, a digital certificate from NASA, and also will be invited to a special virtual event for NASA just for students that participate in this contest. And there will be an astronaut, which is exciting. And then, so next after that, once we choose those semifinalists, then we choose national finalists. So there's gonna be 3 national finalists per age group. And those students will win a trip with a parent to NASA Johnson Space Center to learn all about space exploration and the moon and get hands-on with everything NASA. And then ultimately, there'll be one winner in each age group that goes to the first Artemis 1 launch, which I know Amy is going to tell you all about. And they get to see SLS, the most powerful rocket in the world, take off, which is very exciting. So I don't want to move on without mentioning this very important part, which is all of these education resources. So if you go down to the bottom of the site, you'll see there are a ton of links and lessons for educators to teach this contest in your classroom, as well. If you click over here, there's a brainstorm and design section, which gives students little buckets of consideration to think about when they're designing their expedition on the moon and what skills and traits they might think might be helpful for their crew. So you can use this on your own, or you can just send students to the site and they can dive in and go through all of these resources as well. Another important resource, I know a lot of us are teaching virtually right now, is that we have this little flyer. So if you're doing virtual classrooms or things like that, or if you have a wall to put it on, you can you can put up this little contest flyer to drum up some excitement with your students. And also we have lots of multimedia and videos, and there's one video up at the top, this launch video, which I normally would play, but sometimes in these Zoom conferences, we have some playback issues, but there's a really awesome, cool launch video just for this challenge that you can use to kick off the challenge with your students in class. So that's a really big overview of the Artemis Moon Pod Essay Contest, but all of this is to get students excited about Artemis and about the fact that we're going back to the moon. So without further ado, I'm going to pass it over to Amy, who's going to tell you all about NASA's Artemis program. And Amy, I'm going to pull up your slides real quick, okay?
Sure, thank you. I am so excited. This has been so fun to be a part of with the Artemis program. So I'm going to talk to you guys a little bit about what Artemis is, what we're working on at NASA, and then as Deanne mentioned, going back to the moon. I am so excited. I'm a huge moon fan. I wasn't around alive when we landed the first time, and so I've gotten to work with a lot of astronauts, a lot of my parents' generation that got to see the moon landing. And so it's been very, very exciting to hear their memories and see their stories. And what's really exciting as we talk about this contest and what we're doing with NASA and Artemis is we are the Artemis generation. So all the students that you're influencing and that you're talking with and inspiring every day in the classroom is the generation that we're going to be taking with us, not only with Artemis, but on our way to Mars. So everything that we're building now, I'll talk a little bit about our rocket and our spacecraft that we mentioned, the architecture that we're designing, the human lander systems. I mean, I could just go on and on and on about all the wonderful things that we're doing. Your students are going to be the ones working on this stuff, piloting it, being our astronauts that are going to be informing what we're doing on the moon and going to Mars. So next slide, Deanne. As I mentioned, we were at the moon 50 years ago. We had last year, 2019 was the 50th anniversary of the Apollo 11 landing. And so what we want to talk about too is the Apollo missions. Humans have always had the innate want and drive to explore and discover. And it's time now with the Artemis missions to go forward again. Next slide. I love this slide. You can see here Mike Collins here 50 years ago. I mentioned Apollo 11. Since then, since we've landed on the moon, we've had decades of technological advancement and scientific discoveries. So a lot of things that we're talking about in the Artemis missions now, the things that we're designing, way, way, way more advanced than we had in Apollo. Next slide. So Apollo changed the world. The impact was rippling. It's still beyond that what we can measure. A lot of the spin-off technologies that we had with Apollo and Artemis will do the same, but we have a little bit of different vision this time for when we're going on these missions. Next slide. As I mentioned, we're going eventually to Mars. So we call this our moon to Mars kind of missions. And what's really interesting about Artemis, this is a little bit different than Apollo, is that we're going to stay. So we've got plans, Artemis plans to stay on the moon, to explore, to build an Artemis base camp. And we've got some information and some links that I'll share after the chat about that. Next slide. So what is Artemis? We get this question a lot. Artemis is actually the twin sister of Apollo, so it's very appropriately named. And she was the goddess of the moon in Greek mythology. Now she's personifying our kind of missions to the moon. So it's a wonderful name, very, very exciting. And she's defining this mission with the lunar exploration and what is possible. So now I'm going to get into, next slide, some of the really, really cool stuff that if you were to win the grand prize of our contest that you would actually get to see. So as we talked about earlier, this isn't drawings anymore. This is real. We are building this rocket. This is the Space Launch System, the mega rocket that's going to take us to the moon for our mission. So I'm going to talk a little bit briefly about our first 3 missions, these earlier Artemis missions. And we are so very excited. This is our moon rocket. So if you want to go to the next slide, this is actually real hardware. And why I'm really excited to see this is we're bringing back the NASA worm logo. So yes, very exciting stuff. We're seeing it. Not only these are our twin boosters that we're painting and getting ready for the SLS rocket. You can see the vintage NASA logo on there. What we usually typically have is the blue logo that we lovingly call our meatball logo. We're going to have that on the rocket and everything as well. But this is really bringing it back. You can actually see real hardware for the side boosters of our rocket. So this is down at Kennedy Space Center in Florida. And then next slide, the project that I work very, very closely on is the Orion spacecraft. So this first mission, Artemis 1, that's launching next year in 2021, is uncrewed. This allows us to go out into deep space, try out the rocket, experiment with the spacecraft, fly out to the moon without any astronauts on board. That lets us check out our safety systems, all of our computer equipment and products and things on the spacecraft safely before we return it home. So if you want to go to the next slide, this I'm super excited to share about. This is the spacecraft. So we've got multiple spacecrafts in production right now. This is the actual Artemis 1 spacecraft that will be loaded onto the rocket. And you can see just for scale, some of our engineers at the Kennedy Space Center, right there at the bottom, you can see how massive this spacecraft is. So we're finally right now closing out some final checkouts, making sure that the electronics work, the computer systems work. You can see the silver part at the top is the crew module. That's Orion itself that the astronauts for Artemis 2 and 3 would be in. You can see below it is our service module. What's exciting about this is that this is not just a national program and project that we're working on. This is international. So this was built by our friends in Europe, the European Space Agency. So this is so exciting to see that we're not showing these graphics anymore. We're moving past the drawing board. We are launching next year. So we just have a couple more slides. Next slide. I mentioned Artemis 2. This will be our first opportunity with crew that we're going to be sending our astronauts to the moon, not landing, but checking out around the moon. We'll actually have 4 astronauts. This will be launching in 2023. So we typically announce crew 2 years before a flown mission. So starting next year, we're really going to start seeing a lot of news ramping up about who that Artemis class is going to be going to the moon. And then next slide. The one that we're all waiting for is Artemis 3. So this is what NASA's really committed to, of putting our astronauts on the moon by 2024. So we are working so very hard for so many different things that we're doing, not only the rocket and the spacecraft that I mentioned, but the lander systems, the lunar terrain vehicles. I've got so many things I could share about that we're building now. That's super exciting. So with our last slide, I just want to encourage everyone, and we'll put a lot of links in the chat. we also mentioned on the challenge website too, is this is our #1 website, nasa.gov/Artemis, to hear any updates, and please tune into all the different wonderful things that we're doing with the mission. So Deanne, I'll turn it back to you to talk more and answer any questions.
Great. So what we're going to do now is we're going to take a bunch of questions, and because I know everyone always has a ton of questions for NASA, so we're so excited to have Amy here. So Amy ended with the website for all things Artemis. So that you know, Tanya, one of the Future Engineers representatives, is on chat, and she's going to be putting up some links as well. So futureengineers.org is where you go for the contest and to sign up. So do that now. Right now, and then we're going to start taking some questions. But I'm going to start first. So, I don't know if I said it. Just to hammer this home, we're sending the first woman and next man to the moon, which is super exciting. As me, a huge advocate for women in STEM, I can only imagine how inspiring that is, and it's so apropos with the namesake Artemis. But this time is very different. Obviously, we live in a very technologically advanced society now. I just saw in the news that there's going to be a 4G network on the moon.
Yes.
So talk to me a little bit about this difference and how it's going to be different this time. I mean, in 1969, people watched it on black and white TV. Now we have astronauts who take selfies and post on social media on the moon.
Oh, yes.
Absolutely.
Yes. This is exciting. You mentioned that yes, the internet, having that on the moon, to have the ability to connect with us even faster. And you're right, I missed a huge talking point, and you're absolutely correct. This will be an opportunity for the first woman and the next man to land. This has caused a lot of excitement, inspiration for our young girls in STEM, even our workforce at NASA, that we're going to be able to do this. So there weren't as many opportunities at all, actually, in the Apollo missions to do that. And so to be able to do that and have a woman on the moon is huge. This is huge. As you probably saw in the news a lot with our partners with the International Space Station, it was really big news last year with the all-women spacewalk. I mean, that was amazing. All the went viral. And so we're trying to do more and inspire our women with deep space exploration too. So huge point. I'm so glad that you brought that up. Very, very big deal.
Awesome. So it's going to be different this time. We're going back to the moon. It's different this time on many levels, including technology. Can you talk a little bit about the moon landers? Because right now there's different companies vying for moon landers, right? So can you touch on that a little bit?
Yes, we have a contract out. We've got 3 different companies working on human lander systems. And so we've got SpaceX as one of our companies, Blue Origin, and then Dynetics. And so they've got 3 very, very different prototypes that they're working on now, that they're going to be competing for, to see with the different technologies that they're proposing with NASA. So we've been watching that very, very closely. They've been very great to work with as partners to see, but then one will definitely be chosen and integrated into the technology that NASA's working on to be able to land on the moon. So definitely we've got 3 different partners that are working on that. Very, very exciting technology.
So a lot of us that have been in space education for a while have been talking a lot about Mars. And I know that with Artemis, the moon is a stepping stone towards going to Mars. So, in the Apollo days, it was really the goal was to get there and to set foot and to accomplish that, right? So now that that's been done, the goal really now is to establish the sustainable technologies to live on the moon, correct? So when we think about that, I mean, we're talking 1 or 2 days, or what's the grand plan of Artemis?
So for Artemis, I want to say for 3, they're going to be on there for about a week. So doing excursions, doing traveling and getting samples. That's one thing that's very, very important. Part of the science of Artemis too is we need more lunar samples. So that's one of the many, many goals. I talked about the Artemis base camp. There's different long-term goals, sustainable goals about staying on the moon. But it's interesting because we get a lot of questions about, I mentioned the International Space Station. And yes, we're living and working in space. It's fantastic, but that's low Earth orbit. Nothing against low Earth orbit, but it's when we're landing on the moon, we're actually almost living and working on a different world. So as we know that the moon is way, way further out than the space station. And so we're going to be actually off the spacecraft, doing moonwalks, doing things that we haven't done for 50 years and doing it longer. When the Apollo astronauts were on the moon, they were out for hours at a time. We're talking days, weeks that we're going to be out there studying and exploring. So very, very big difference for these kind of missions.
And I'm going to do one more question before we transition to all of our chat questions. And that is, so in the Artemis Moonpod essay contest, we specifically tell students that it's a 1-week expedition at the lunar South Pole.
Yes.
So the South Pole specifically, why is that such an exciting region for NASA?
It's really interesting. We've been studying not only the area. We didn't explore this region during the Apollo missions. We stayed more towards the equator, or more kind of the center part of the moon. We never explored the poles. So that's one key difference, is that we didn't try it out for Apollo, and also because of the water ice that's there. There's a lot of science, a rich geology, and also the ice and water, potential for water that they're finding with previous missions and things that we've studied before. So it's a huge kind of area, a resource rich area that we're exploring. So very, very different. I think just personally, it's amazing to try just a pole versus kind of the larger different areas of the moon. So very rich in science.
Awesome. Hi, Dave. I know we're taking some audience questions, and hopefully you're triaging.
You're doing such a good job. I was just sitting here listening and enjoying it. Keep going, Dave.
I'll give you the next question, Dave. Why are you excited about going to the moon?
Yeah, I want to hear what you think.
You know, I was a youngster. I was alive in the first one, and
I'm so jealous.
Well, I vaguely remember. I was very young, but I do remember it, and I do remember what a big deal it was. And you know, how did we not? I guess this is for you, Amy. Why did it take 50 years to say we need to do this again?
It's interesting. We get that question a lot. Some of it's funding for exploring deep space. Sometimes we get the critics and things that, you know, we've been there, we've done that, we've got to move on to something else. So it was interesting as Apollo was kind of coming to an end, and we were looking at different things with NASA. That's when we started the space shuttle program. So we were looking at something near, I mentioned low Earth orbit. So how we're going to we put up Hubble. We've got the space station. We're building that, which, by the way, I keep mentioning the space station. I'm so excited. Next week on, let's see, November 2nd is our 20th anniversary. So it's a big, big deal for space station. And why that's important, it's the 20th anniversary of continuous human presence on the space station. And the space station, the work that we're doing with space station is so important because it's informing us. We mentioned living in space and what we're doing for the Artemis mission. So everything's connected. But to answer your question, Dave, a lot of it was funding. A lot of it, just the political environment at the time. I mean, we get that, especially with the 50th anniversary. Why is it taking us so long to get back? And I think a lot of it too is how we're allocating the funding that we do get. And so at that time, the space shuttle was the biggest thing. You know, as you know, it went for 30 years, and the space station. So now what's very exciting, we mentioned our partners earlier. We've got SpaceX and Boeing that's helping us with these new crew launches to the space station. This is freeing up resources, time, expertise to take us to deep space. So that's why this is kind of happening again, where we're going out to the moon. It's been time, and we're very excited to do it.
It's interesting.
I have sorry.
I was just saying, it's interesting that there's private companies like SpaceX and Blue Origin that, you know, they're funding a lot of it, right? You know, and they see it as an opportunity for them.
Sure.
Go ahead, Deanne.
Yeah, I have a question. There was a really good question that came in that's kind of near and dear to my heart, which is, does the moon have resources that we're going to exploit? And I'm going to give a little brief answer, which is Future Engineers got its start doing 3D printing challenges on the space station and working with NASA's Advanced Manufacturing 3D Printing and Space Group. And one of the big buzzwords is in situ resources. So what resources are there that you can use instead of bring them on the rocket, because you want to bring as much useful stuff as you can on the rocket, right? So that group was working on 3D printed habitats using lunar soil, right? Building a whole, you know, house or radiation shield out of lunar soil. And I know there's so many other resources, so I don't know if you want to touch on that at all, Amy, but this idea of using things on the moon, not just taking everything with you like we have to do on the space station.
Sure. No, you mentioned exactly what we're looking at for using the regolith or the moon soil to build a lot of the bases of creating the 3D printing. That's a lot. I mentioned the water ice. They're looking at ways now to even make rocket fuel out of some of the resources on the moon. So there's a lot of science there that we're trying to take advantage of, because as you mentioned, it's very difficult to take a lot of you think of weight and mass and different things that we've got to launch with us with the space launch system. So the more that we can utilize the resources, not only with the moon, but we're learning this with Mars as well, with the rovers that we're sending and the different science that we're doing in Mars, that's informing us a lot with deep space as well. What kind of resources can we use on these other worlds and planets to help us for this deep space?
And we just had a question about deep space. Like, what exactly is deep space? Is that so? The moon is not deep space. Is Mars deep space? How far is deep space?
I actually don't. I wish I had the graphic. We actually have linear delineations of where we actually consider the Earth, moon almost its own little system. We call it the cislunar system. So it's kind of our own home system. And so there's different measurements, and I can add that information later about where we consider deep space. But from what I understand, is just past the moon. So we consider just past the moon deep space and beyond. But we actually call the space between the moon and Earth cislunar space. And so I just don't have it in front of me, but I'd love to give you the actual numbers so that you can see what we consider it. But yes, low Earth orbit, where the space station is, cislunar space and deep space.
You know what we can do, Amy, is there's a Facebook group for this whole conference. So afterwards, if you follow up, we can post that on that Facebook group.
I would love to, yes.
And we'll follow up with information about the contest as well. We have an important question that came in that we should clarify, which is this contest open to international students? And I should caveat that the Artemis Moonpad Essay Contest is for US students. But there are opportunities for international students to participate in the Artemis program and NASA in general. And particularly, there's a social campaign running right now. So Amy, do you want to chat about that?
Yes, we have a campaign. It's called #NASAMoonKit. This has been so much fun. We've launched it in October. We're extending it into November. And you can post on Facebook, Twitter, or Instagram what you would take to the moon. So this has been very, very fun. We've got companies, celebrities, kids, teachers, classroom students are posting what they would actually take to the moon. So we've actually got an expert mode challenge where we give dimensions, and we can put this in the Facebook group and the chat later, of if you were to actually bring the dimensions of what you can take to the moon if you were an astronaut. So it's actually very, very small. So it's a very expert mode challenge, but we've been, all you do is to take a photograph. And so what would you take to the moon? People have been putting family photos, their own personal teddy bears. It's been really exciting. NASA gear. People have been, I think some of the most fun things I've seen are people that want to explore. So they'll bring mountain climbing gear or something like that. So that's something that we're seeing international participation. It's open globally, that we'd love to see what you would bring to the moon.
Great. So
Amy, this maybe is a dumb question, but I'm thinking about the International Space Station. So it's not hugely further to go to the moon because you've used all the energy to get out of Earth's atmosphere and get there. But there must be something about the amount of energy to land on the moon and then take off again that makes it something that it's different than the International Space Station. Am I thinking about that right?
I think I understand. So I think you're talking about with the energy to be able to get, if you probably remember with the Saturn V rocket and how massive that rocket was, we needed that. There was different upper stages. There was different things that we need to be able to propel us to go to the moon. For the space station, we don't need, with the power, because it's only going to low Earth orbit, we don't need as much power and much thrust because we're not going as far the distance. So I don't know if that's answering your question, but sometimes we actually, okay. So that's why the Space Launch System is such a massive rocket, because not only is it we need the fuel, we've got the different stages, the smaller rockets that are taking us, propelling us to be able to go the distance to the moon.
Well, that's, my next thought from that was, well, if it was not that much further, and it is for more energy to get there, but why not have a moon station instead of a space station where you could store stuff?
We're actually building that. We're building the Lunar Gateway. That's something that I did not mention, only because to keep this talk brief, I only mentioned the first 3 missions. We've got later Artemis missions that we're building the Lunar Gateway. And I can add more information in the chat in the Facebook group. This is super, super exciting because it's a gateway. It's almost a station going around the moon where we're going to have astronauts be able to stay and launch off to go to Mars. And you're right, to have things, to have science. It's smaller than the space station, the International Space Station, but we have plans to build. This is more missions, Artemis 4 and beyond, that will be doing this with the human lander systems. But you're absolutely right. That's the thinking that we have with the architecture.
And something that's really cool to think about the ISS transitioning to the moon is there's so many sustainable technologies that have been developed on the ISS. I mean, I don't know if you know, but they can recycle their pee back into water that they drink, right?
Yes.
All of these amazing systems, which now, as you go onto the moon, those systems that have been proven on the ISS can be used. But what's interesting is the ISS, you said, has been manned for 20 years. But when we think about the moon, there's going to be times where they're there for a week and they leave, but there can be robotic manning, right?
Yes.
Of autonomous systems that stay behind, right?
Yes. One of them that we're building is called Viper, and I'm making notes here. I'm going to send you guys some information. It's really, really cool. A new robot, almost a lander that we're posting and putting on the moon. So that's going to be doing science. The Gateway too. That's another question we get too. If there's no astronauts on Gateway, will it still be operational? And the answer is no. It'll almost be in sleep mode for saving energy and things like that. It will only be operational doing things once we have astronauts on board. But we will be able to work with these rovers, much like we do with Mars and how the teams do with the rovers, to be able to connect with them on the lunar surface. So that's very, very exciting. But you're right. We've got other vehicles and things in the works that we'll be deploying in the Artemis missions as well.